energy lab, going from EG, gravitational potential, to kinetic energy. We are priming the students for this lab. If you see my slides, I have them already reading about gravitational potential and kinetic energy. They've also done energy transform worksheet before they're doing this lab. So another thing to note is that they all have to do multiple heights, so there's no board meeting. There's no authentic reason for them to share data since they have the same data. So let's go and take a peek at the experimental setup. The same setup we've been seeing the last couple times, except for now every group has to do every height. So the groups need to start lower, not too low where the ball actually comes to a stop. These ball bearings are pretty good, so they roll pretty well. So I might have this my lowest height, height 1, height 2, put it up here, height 3, and then height 4, and one other height, maybe height 0. Doesn't have any velocity, so we get our 5 heights there. Now, again, the data is actually taken at the end of the ramp. We are just starting it at different heights. So in fact, another creative way to do this is to have the same ramp the whole time. And you start it here for 1 height, 2nd height, 3rd height, 4th height, 5th height. In fact, that's probably quicker and easier. So we'll do height 1. We're going to let it roll to the starting line, and then we start. And then it's stopped. So we always let it go 2 meters so we can find out the velocity. The velocity then is just going to be 2 meters divided by the time. Velocity equals distance divided by time. So we have different starting heights, and then we get different velocities at the end of the ramp. From there, we're going to go, and they're going to go into Logger Pro. Again, we're using the simplest best fit line, y equals ax squared. They're going to get something really close to height equals 0.07 times v squared. That's excellent. And with their reading, and you can check my slides for how I guide them, we want them to make the connection, the empirical connection here, to the more general form, mph equals 1/2 mv squared. Now this ramp lab is going to show up again in the beginning of learning target 3 with forces, where they are going to start a ball at the top on carpet and have to predict what speed it's going to get up to, and then where it's finally going to slow down to a stop because of